So far, we've worked with limits that evaluate to a number. We've worked that limits that you observe a graph to see what happens from both sides. And we've looked at a graph where the limit just didn't exist. Today we're going to be talking about one-sided and two-sided limits. Sometimes the value of a function f tend to be different in limits when x approaches a number c from opposite sides. When this happens, we call the limit of f as x approaches c from the right-hand limit of c, and the limit as x approaches c from the left is called the left-hand limit. So it's also very important to note that right-hand and left-hand limits are behaviors. They're not actual values. It's just what the graph approaches, the behavior of the graph. It sometimes is a number, but right-hand and left-hand limits can be infinity, where an actual limit cannot. It has to be a number. Example 7. In this example, we're going to look at a very popular function called the integer function. So we represent that by int. Some know this also as the step function. The way this works is that you always round down the number. So for example, if f of x is int of x, and I want to find f of 3. So it's int of 3, which is just 3, because if you round 3 down, you get 3, and that's why we have a solid dot at 3. If I want to find f of 3.5, it's int of 3.5, which is also 3. Notice that we round down. So f of 3.9 is still just 3. F of 3.99 is still 3. It does not become 4 until you get to 4. So now we're going to look at some left-hand and right-hand limits using this. So let's look at the limit as x approaches 2 from the right of our integer function. So as we approach 2 from the right, here's 2, and we're going to approach it from the right, so we're going to be heading this way to it. So then that y value is then 2, because we're approaching this closed dot. Now we're going to look at the limit as x approaches 2 from the left of the integer function. So as we approach 2 from the left, we're getting very, very close, but we don't actually get to 2. We just approach it. So then the y value here is 1. Even though it's an open dot, f of 2 is 2. However, the limit from the left is 1 because we don't actually get to 2. We just get to 1.9999999 forever. Okay, and then I'm going to put 2 problems up, and I want you to try them on your own. The limit as x approaches 4 from the right of the integer function, and the limit as x approaches 4 from the left of the integer function. So go ahead and give those a try. Okay, so as we approach 4 from the right, we're going to be heading towards this number right here. So we're going to be mainly focused in this area here. So as we approach 4 from the right, we notice that we get 4. And as we approach 4 from the left, you'll notice that we get 3. And that's how you do right and left limits.